Hey guys, welcome back. Last section of Unit 7, Section 7.5, the vertex of the parabola, applications and modeling. So we're going to jump right into it. Example 1 says f of x equals a parentheses x minus h squared plus k, where a cannot equal 0. Remember that this is the vertex form of a parabola. So what they want us to do is given an equation. So they gave us f of x equals x squared plus 8x plus 13. They want us to first rewrite the problem in vertex form and then identify the vertex, the axis of symmetry, and if it has a max or min value. So you're probably wondering, how are we going to change our regular standard form, x squared plus 8x plus 13, to the vertex form? So here's a hint. We're going to refer back to our 7.1 notes on completing the square. So we start with part A. We have our equation f of x equals x squared plus 8x plus 13. The first thing I'm going to do is remember, f of x is always the same thing as saying the y equals. So I'm going to rewrite this to say y equals x squared plus 8x plus 13. And now I'm going to do my change. So remember, in order to do completing the square, we want our variables here, the x squares and the x, 8x, to be by themselves. So I'm going to subtract 13 to the other side. So I'm going to say subtract 13 over. So I'm going to see y minus 13, and I'm going to put a blank because remember, when completing the square happens, you need to balance the boat. So I'm doing my blanks. Completing the square affects the right side here. So first thing we got to do is figure out what our value is. Remember, this is our b. So you're going to do 8 divided by 2 and then square it. So we have 4 squared equal to 16. So I'm going to write 16 on the right side and 16 on the left side. Consolidate by combining like terms on the left. So we have y plus 3, because short $13 and found 16, I have 3. On the right side is going to collapse the bubble power of 2. Remember, the square root of 16 is what got us there. That's going to be a 4. The sign in the middle is positive, so that's why it's a plus, and then a plain x. The last part is to bring the 3 back over. So I'm going to subtract 3 to the right. So we become y equals parentheses x plus 4 squared minus 3. So now I'm in the function form for if I needed to graph this. So now part B want us to find the vertex, our axis of symmetry, and if it has a max or min. So our vertex, when we look at our vertex, remember it's the opposite in the sign. Our vertex is located here. So I had a positive 4, but remember it came out as a negative. So it's negative 4. The k value is negative 3. It stayed negative 3. Axis of symmetry, remember that's equal to the x coordinate. So our x value was a negative 4. Our y max min value, it's always the y component. So we know that y is equal to negative 3 because that is the vertex point there. But here the problem is it's knowing if it's a max or min. So we need to know what our a value is. Well, our a value is always the number in front of the parentheses. In this instance, it's a 1. We imply a 1 there. We don't have to write it in. But we know that a is positive. So since the a value is a positive number, we have a bowl of soup, it's opening up, which means we have a minimum value. Okay, example 2 says f of x equals negative 2x squared plus 12x minus 16. Again, for part A, they want us to rewrite it in vertex form. B, they want us to find the vertex, the axis of symmetry, determine the max and min value. C, now they want us to find your x and y intercepts. And D, graph the function. So we're going to start with part A, which says rewrite. So we're going to take our equation, f of x equals negative 2x squared plus 12x minus 16. And we're going to do this a little bit differently than we normally do completing the square because of the vertex form. So again, we have y equals negative 2x squared plus 12x minus 16. First thing we're going to do is going to move the 16 to the left. So we're adding 16 over. So we have y plus 16 plus, I'm going to do a double blank line here, equals negative 2x squared plus 12x plus a single blank. And the reason being is because the leading coefficient here is a -2. In the past, for completing the square, we would divide everything by that -2 to make that a leading coefficient of 1. But because it's going into vertex form, we cannot do that. We're not dividing by the -2 to everything. We're just factoring out the -2 here. So y plus 16 and our double blank slide down. I'm taking out the -2 by factoring out a -2. So if I divide this by -2, I get x squared. Divide positive 12 by -2, I'm a -6x blank. And still the same thing, because if I were to distribute back in, there's my -2x squared, negative and makes it positive 12x squared. The parentheses here is where we're going to do our completing the square. So in this instance, our b value is a -6, which we divide by 2. So we have -3 squared makes it a 9. This is where it gets a little tricky and you need to remember. 9 is the blank. 9 is not the double blank. 9 is on the inside here. We did something to get there. So the -2 that we factored out needs to be multiplied in to balance both sides of the equation. So I'm going to do -2 and 9 and make it -18. That is what you are adding to the left side of the paper. Consolidate your numbers here. So I had $16 but spent 18. I'm short 2. -2 stayed. Remember, this breaks down to the power of bubble power of 2. We had a square root of 9. That was a 3 that got us there. Sign is a negative in the middle, and then our x. The last step is bring the 2 over so you have your k value where it needs to be. So y is equal to -2 x minus 3 squared plus 2. Now we are in the correct vertex form. So that is part A. Part B wanted us, we need to find our vertex, our axis of symmetry, and then if we have a max or min value. So first thing, when we look at our vertex, remember, if it's negative inside, it's going to come out positive. So it's an x minus 3. I'm going to be x equal to 3. So I'm a positive 3. It's a positive 2. I'm a positive 2. Our axis of symmetry is tied into our vertex. So it's always the x coordinate of the vertex. So it's at x equal to 3. Our max min is tied into the y component of the vertex. So we know the y value is a 2, but we need to know max min. Remember, your a value in this instance, according to our problem, is equal to a -2, which means it's opening down. So we have a maximum peak. Part C is asking us to identify the x and y intercepts. So that can actually go back to your original problem. So when we look at original problem, it was -2x squared plus 12x minus 16. I am going to first, in order to find out our x-intercepts, I'm going to factor out the -2 out of all of them. So we have -2, we have x squared, -6x, positive 8. I'm going to factor this. This is where I'm going to find my x and y intercepts. So -2 is still there, doesn't do anything to our problem. Numbers that multiply to be 8, that add to be -6. I think of 4 and 2 if they're both negative. So x minus 4, x minus 2. So we have an x value at 4 and x at 2. That means that our graph isn't across the x-axis at 4 and 2, at the ordered pairs. Remember, intercepts always have ordered pairs. So we have a 4, 0 and a 2, 0. That is the x-intercepts. These are our x-intercepts. Then they want the y-intercept. Remember, to find the y-intercept, take your original equation. F of x equal to -2x squared plus 12x minus 16. Replace all your x's with 0. So I have -2 times 0 squared, 12 times 0, -16. If we do our math, these cancel themselves out and we're just left with -16. So our y-intercept is at 0, -16. Part D of this problem wanted us to graph the function, so just give me 1 sec. Okay, so to graph this problem, I've already set up our equation. F of x is equal to -2, x minus 3 squared plus 2. All I did was write the vertex form. And I've already identified the key features we did and found, which is our vertex is located at 3, 2. Our axis of symmetry is at x equal to 3. The maximum value is located at y equal to 2. I brought over our x-intercepts. So our graph has the parabola going through 4, 0 and 2, 0, and it's going to hit the y-axis at 0, -16. So based on this, we don't have to do a parent function anymore. We can use our x and y-intercepts to graph our pieces. So it has an x-intercept at 4, 0 and 2, 0. So at 4, 0, we have a point, and at 2, 0, we have a point. The next thing it says the y-intercept hits the y-axis at 0, -16, so it's hitting down here at 0, -16. The other piece information says that the vertex is located at 3, 2. So here's 2, here's 4, halfway's 3, up to the 2 axis. There is our peak value of our thing, and we have an imaginary axis of symmetry. That's where it goes through. So we're going to draw a dashed line through our location of our x point, so we know that it'll split our graph in half. Since we have these 3 points here, this is located out 3 units out from the y-axis, so I'm going to go 3 units out from the y-axis. So then I have 5 points. And do your curve, and we have our parabola.